dear students, we had discussed lever in the last video. Today we shall start with pulleys. So what is a pulley? What is a pulley? A pulley is a metallic disc with a groove rim. A string or a rope is passed around the groove at the rim. The disc rotates about an axle passing through its center. The axle is fixed rigidly to frame by means of a nail. So what is a pulley? A pulley is a disc that has got grooves, and a rope is wounded around the grooves in the pulley, and the pulley is hanging to a rigid support, and when we pull the string, the pulley rotates due to friction. So here a pulley is a wooden disc that is hanging to the frame. This is the frame, and there are grooves. Grooved rim means kinare, and a tackle is put over the pulley to make the pulley rotate. So this is a pulley. Now there can be two kinds of pulley: a single fixed pulley or a single movable pulley. Now single fixed pulley, when you talk about a single fixed pulley, the point of rotation or the axis of rotation is kept stationary. It is fixed. There is a hole in the center. There is a hole at the center. You can see there is a nail that has been put in this hole. So there is a hole in the center, and we put the rod, which is the axis about which the pulley is rotating, and then it is being fixed. So the pulley keeps on rotating at the same position with that is known as a single fixed pulley. And the second kind of pulley is a movable pulley, where the axis of rotation is also changing its position. That is a single movable pulley. This is a single fixed pulley. Here the axis of rotation, the axle, is stationary. The pulley can rotate at a fixed point about this axis. Okay. So we have a single fixed pulley which is hanged to a rigid support. It is being held to a rigid support. There is a string that has been put around this grooved rim. There is a string that has been put around the grooved ring, and both the ends of the string, there are two open ends of the string. One end we have hanged certain amount of weight, that's known as load, and the other end we are applying effort. What are we doing? We are pulling this load in the upward direction. So there is a load that is hanged at one end, and there is an effort that is acting at the other end. So there are two ends that are there, at which the load is acting, two free ends, and one where load is being hanged. Now we consider this part only. This load is stretching the string. So there is a tension that is acting in the string in the upward direction, and there is another force that is acting at the other end, that is effort by which we are pulling the string. So this effort is balanced again by tension T. What is T? Tension. So at both the free ends of the pulley there are tensions that are acting. The direction of the tension is in the upward direction. Now I have written T on both the ends. I have not written T1 and T2. It means that the tension in a single string is always same. The tension in a single string is always the same. You cannot have T1 and T2, otherwise they will have a resultant tension, and the string will keep on moving on its own because of the resultant tension. So in a single string, the tension at both the free ends are same, and they are always acting towards the rigid support that is in the upward direction. So we will find out the mechanical advantage and velocity ratio of this single fixed pulley. So we have got two in our system. We have got two things: load. There is load. We are finding out mechanical advantage. Now mechanical advantage is equal to load upon effort. Here in the single pulley, the load is being balanced by the tension. So load is equal to T, and at the other end the effort is also equal advantage is equal to T upon T equal to 1. So mechanical advantage of single fixed pulley is equal to 1. That is, it is not acting as a force multiplier or nor it is acting as a gain in speed. It is only used for changing the direction. Then the second one, we have to talk about velocity ratio. What is velocity ratio? Displacement of effort upon displacement of load. Now suppose let us pull this string by a distance dE in the downward direction. Or to make it simpler, if I pull this string, the effort end 1 meter down, how much the load will get lifted up? 1 meter only. If I pull this string 1 meter down in the downward direction, the load will also get lifted up by 1 meter only. It means the displacement of effort and displacement of load, which are in the opposite direction, the displacement of effort is equal to displacement of load. So this is dE upon dL, and in a single fixed pulley, dE equal to dL. Therefore, it is equal to 1. Then we have efficiency. Efficiency is equal to MA upon VR. Since MA is equal to 1 and VR is also equal to 1, therefore efficiency is equal to 100%. So efficiency of a single fixed pulley is 100% in an ideal condition. We are not taking into consideration the frictional force acting between the axle and the pulley or between the gears of the pulley. Is it clear? So we are not talking about and there is no frictional force acting between the axle and the pulley. So that is, it is here. Then only in the ideal condition, and we are not considering the mass of the pulley. Actually, in the single fixed pulley, the mass is itself balanced on the axle because it is being hanged by a rigid support. So this pulley, mechanical advantage equal to 1. It is not acting as a force multiplier. Neither we are getting any gain in speed because velocity ratio is also equal to 1. So what is the purpose of using this single fixed pulley? You must have seen this single fixed pulley at different well to lift load. Whenever we have to lift load, like a crane that is using a single fixed pulley to lift the load. So what is the purpose? The purpose is only to change the direction because it is easier to pull down than to pull up. If we are, suppose we are pulling up 10 kg of water from the well, so to pull it in the upward direction against the gravity is difficult than to pull it down. So single fixed pulley is used to change the direction of pulling. Okay, we are pulling it in the downward direction, that is in the direction of the gravity. That is in the direction of the gravity. Is it clear? Next we have single movable pulley. A single movable pulley is the one in which the axial rotation is movable. This pulley, mechanical advantage equal to 1. It is not acting as a force multiplier. Neither we are getting any gain in speed because velocity ratio is also equal to 1. So what is the purpose of using this single fixed pulley? You must have seen this single fixed pulley at different well to lift load. Whenever we have to lift load, like a crane that is using a single fixed pulley to lift the load. So what is the purpose? The purpose is only to change the direction because it is easier to pull down than to pull up. If we are, suppose we are pulling up 10 kg of water from the well, so to pull it in the upward direction against the gravity is difficult than to pull it down. So single fixed pulley is used to change the direction of change the direction of pulling. Okay, we are pulling it in the downward direction, that is along the in the direction of the gravity. That is in the direction of the gravity. Is it clear? Next we have single movable pulley. A single movable pulley is the one in which the axial rotation is movable. So here is a diagram for a single movable pulley. One end of the string is being fixed to a rigid support, and the pulley is on the tackle or on the string. It is free on the string. So this pulley is of negligible mass placed over an inextensible string. There is a load that is hanging to the frame of the pulley. So load L that is hanging to the frame of the pulley. This is tight. Now there is an effort that is acting in the upward direction. Now effort is acting in the upward direction, that is at the free end. The tension T acts on the string on both the sides of the pulley as shown in the figure. So there are tension T and T acting on both the sides of the pulley. They are all acting towards the rigid end, that is in the upward direction. Now we will find out the mechanical advantage, velocity ratio and efficiency of the pulley, single movable pulley. So first of all, let us see load. This load is acting in the downward direction. The direction of the load is in the downward direction, and it is being supported by two segments of the string. There are two segments, this one and this one. These are two segments of the string. They are tension acting in the string. So there are two T's that are acting in the upward direction. So load L is supported by T plus T, that is equal to 2T in the upward direction. And effort is always equivalent to single T's. Effort E is always equal to P. Therefore, mechanical advantage is equal to load upon effort is equal to 2T upon T. T cancelled out is equal to T. So, here mechanical advantage is greater than 1. It is equal to 2. What does this mean? This pulley is used as a force multiplier. Since its mechanical advantage is greater than 1, it is used as a force multiplier. That means if you have to lift a weight of 50 kg, you can apply an effort of only 25 kg. Is it clear? Mechanical advantage equal to 2 means that half the effort is required that of load, or whatever effort you are applying, double the load can be pulled up. Then next we come to the velocity ratio. Velocity ratio. Now velocity ratio is displacement of effort upon displacement of load. Suppose we are pulling this string by 1 meter in the upward direction. How much the load will be pulled up? We are pulling 1 meter this string in the upward direction. So how much the pulley will be pulled up, or the load will go up? Now this pulley has got two segments, one part here and one part here. If we pull 1 meter up, this end 1 meter up, then the load will be lifted only by half or 0.5 meter, because half this direction and half this direction. आधा इधर से खींचेगा, आधा इधर से खींचेगा, तो पुली कितना जाएगी? Half and half. It will make 1. So pulley will go by 1 meter up. Then load will be lifted by 1 by 2, that is 0.5 meter. Then in that case, if the displacement of effort is equal to D, then displacement of load will be equal to D by 2. Velocity ratio is displacement of effort upon displacement of load. So D upon D by 2, that is equal to 2. So velocity ratio is 2. Then we come to efficiency. Efficiency is equal to mechanical advantage upon velocity ratio. This is equal to 2 upon 2 equal to 1 or 100%. So efficiency of a single movable pulley is also 100% in ideal condition, when we consider that the string is inextensible and the pulley is of negligible mass. Okay. So, but there is a problem in this. What is the problem? The effort is being applied in the upward direction. So it is difficult to pull a thing in the upward direction. Some of the students must be thinking that this pulley will go up and it will get stuck to this rigid end. This is a diagrammatic representation. The strings are very long. Okay, it keeps on lifting up to a certain height. So strings are long. It's not shown that it will go slightly up and that it will get stuck to the rigid end. It's not that. So the strings are long. The advantage is there because it is acting as a force multiplier. But the disadvantage is that the effort is being applied in the upward direction. This disadvantage can also be removed if we connect a single movable pulley here and put this string in the direction here. Now this is a combination of a single movable and a single fixed pulley. This is a combination of single movable and a single fixed pulley. What we have done here? We have attached a single movable pulley with a single fixed pulley and changed the direction of the effort in the downward direction. Now what is the mechanical advantage of this kind of combination of pulley? The mechanical advantage is 2. How? 2 of the single movable pulley and into 1 of the single fixed pulley. So this type of combination is being used